welcome to the Supercharged Batteries module on battery testing and servicing. Here we will cover checking, cleaning, jump-starting, testing, charging and replacing a battery, giving you the confidence to deliver an excellent customer experience every time. Battery servicing begins with a thorough visual inspection. This may reveal simple, easily corrected problems or problems that might require battery replacement. Start by checking for cracks in the battery case, broken terminals, cracked or broken cables and connections. Replace as needed. Check for corrosion on terminals and dirt or acid on the case top. Clean the terminals and case top with a mixture of water and baking soda. A wire or terminal brush is needed for corrosion on the terminals. Check for a loose battery hold down and loose cable connections. Tighten as needed. Check the tension and condition of the alternator drive belt. A loose belt will prevent proper charging and must be tightened. A belt that is too tight will reduce alternator life. It should be loosened to manufacturer's specs. A frayed or glazed belt will fail during operation. Replace it. Check for battery drain or parasitic loads using an ammeter. Connect the ammeter in series between the battery negative and ground cable connector. A reading of more than 0.035 amps is too high. Locate the cause of excessive battery drain. Check the level of electrolyte for accessible batteries. The proper level is just below the vent funnel. The least expensive yet most reliable test is just by the use of a digital voltmeter and load tester. If the battery is installed in the vehicle, measure the voltage drop while trying to start the vehicle. In a 12-volt system, the battery voltage should not drop below 9.8 volts while the vehicle starts. If the battery is outside the vehicle, measure the open circuit voltage, connecting the red probe to the positive terminal and the black probe to the negative terminal. While an open circuit voltage test determines the battery's state of charge, it does not measure the battery's ability to deliver adequate cranking power. A capacity or load test is required. A typical load test applies a calibrated load to a battery of at least 12.4 volts, typically half the battery cold cranking amp capacity, or 3 times its amp hour rating. While the load is applied, the tester monitors battery voltage. If the battery voltage drops below 9.6 volts during the test, the battery requires replacement. Handheld battery testers such as conductance testers may be used if it is impossible to do battery testing using the recommended procedure, taking into consideration that there are limitations in doing so, such as the inability to check for internal cut-off connections, which causes a battery to fail once load is introduced. The tester clamps must have good contact with the lead post. Threaded posts on nuts may supply a false test result on most of the handheld testers. Use an adapter for threaded posts as necessary. When jump-starting a dead battery with a booster battery, proper connections must be made to prevent sparks. Note that damage to vehicles' electrics can be caused by an alternator voltage spike. First, connect the 2 positive terminals. Then, connect one end of the jumper cable to the negative terminal of the booster battery and connect the other end to a good ground away from the dead battery. The vehicle should run for 5 minutes before disconnecting the jumper leads. Turn on the headlights of the recipient vehicle prior to disconnecting the jumper leads. A battery in good condition may occasionally fail to crank the engine fast enough to make it start. In such cases, the battery may require charging. All battery chargers operate on the same principle. An electric current is applied to the battery to reverse the chemical action in the cells. Never connect or disconnect leads with the charger turned on. Follow the battery charger manufacturer's instructions and do not attempt to charge a battery with frozen electrolyte. The battery can be considered fully charged when all cells are gassing freely and when there is no change in specific gravity or on-charge voltage readings for more than 1 hour. Depending on the type of battery and temperature, batteries have a natural self-discharge of 1 to 6% per month. Over time, the battery will fully discharge and become sulfated. Batteries stored for any significant period of time need periodic charging. Always charge batteries in a well-ventilated area and wear proper eye protection. Make sure the charger is turned off before connecting the leads to the battery to avoid sparks. Connect the charger leads to the battery, red positive lead to the positive terminal and black negative lead to the negative terminal. Turn the charger on and slowly increase the charging rate until the desired ampere value is reached. If the battery becomes hot, or if gassing or spewing of electrolyte occurs, reduce the charging rate or temporarily discontinue the charge. Always turn the charger off before removing charger leads from the battery to avoid sparks. As the temperature decreases, the electrolyte resists charging. State of charge. A battery that is severely discharged will have high sulfate crystals on its plates. When sulfation covers the complete plate area, the battery may not be restored. Dirt and other impurities in the electrolyte and plates increase charging difficulty. A low voltage output charger will not easily charge a maintenance-free battery with an open circuit voltage of less than 10 volts. Constant current chargers charge a battery at a preset or adjusted rate of constant current. The battery voltage will rise as the state of charge increases. The voltage rise of each battery under charge has a natural limit, usually lower for antimonial batteries and higher for calcium batteries. When the battery is fully charged, the on-charge terminal voltage does not change by more than 0.04 volts on a 12-volt battery per hour for 3 consecutive hours. Any charge after the battery is fully charged will result in increased battery temperature and gassing. Constant voltage chargers charge a battery at a design maximum charging voltage, usually above 13.8 volts and below 17 volts for 12-volt batteries. After a discharged battery has been recharged for a period of time and the desired maximum voltage is reached, the charger controls the charging voltage at a constant level. Initially, the charger will put out the maximum current and voltage demanded by the battery, and the charging current may be high. As the charging continues, the battery's demand for charging power decreases. When the battery is fully charged, the charging current will decrease to a constant minimum. Equalisation is allowed, provided it does not exceed 3 hours after the completion of constant voltage charge. There are different automatic chargers offering fully automatic, safe-to-use features. Some are configured to charge different types of batteries by just selecting appropriate battery type. It is important to choose the correct automatic charger for your battery. In any of the tests conducted, adjudication may either be to replace or to charge a battery for further testing. If adjudication is to replace and the battery is covered by warranty, make a replacement. Otherwise, suggest to a customer to purchase a new one. Battery testing and servicing may seem complicated, but following these steps will ensure that you are providing your customers with the best possible care for their batteries, ultimately ensuring the highest level of customer service.